ass can eat a fat dick. Yeah, Easy E, Easy E, Easy E can eat a big fat dick. Tim Dog can eat a big fat dick. Luke can eat a fat dick. Yeah.
Back to another Swift tutorial. Today we're going to be talking about enumerations in Swift and how they're a little bit different from enumerations in Objective-C. We'll be talking about some of the newer kinds of things that you can do with enumerations. If you have not yet downloaded the beta for Xcode 6, that's absolutely important. That is more or less a requirement of using this tutorial or going through it. So what you want to do is start with a new playground. In this case, we've actually got our own playground defined. One of the newer options in Xcode 6, Beta 4 at this point, is selecting between an iOS playground or a macOS playground. In this case, just pick an iOS playground. So here we are, we're in our playground, and you see that we're importing UIKit for iOS specifically. Let's just ask a really basic question. First of all, what is an enumeration? So an enumeration is basically just a list of things, pretty much, kind of a complete set of things. So for example, if we're talking about planets, there's a certain list of planets that orbit our sun, and that list starts closest in with Mercury, then it's Venus, then Earth, and then Mars, and then on and on and on, until we've actually completed the entire list of planets that orbit our star. In this case, in the song, Dr. Dre and Snoop Dogg make it rather clear that there is a list of particular, shall we say, individuals who can eat a big fat dick. And that list includes Eazy-E, Tim Dog, and Luke in order. And so effectively what Dr. Dre and Snoop Dogg are doing is enumerating through this list of sucka-ass individuals who can eat a big fat dick. Similarly, in Xcode and iOS, this is something that we can do in our own applications. So we can actually declare an enumeration. In this case, we're going to call it our sucka-ass individuals who can eat a big fat dick. And this is all we're doing right here. So we've got some such enumeration declared. We haven't specifically said who belongs to this enumeration or in any order. We're just saying there is some list starting with 0, going on and on, of some individuals that can eat a big fat dick. So we'll actually start declaring the members of that list. So the first member, of course, is Eazy-E. The second member, of course, is Tim Dog and Luke. Okay, and so we've effectively said the first member in the list is Eazy-E, the next one is Tim Dog, and then the third one is Luke. These are pretty much all of the, it is a complete list, which is to say that these are all of the sucka-ass individuals who can eat a big fat dick. There really isn't anybody else outside of this specific list. So we've declared these, and now that we know that this list exists, we can use it. So we can have variables that assume that they are a member of this particular list. So we could say let some individual, okay, some person who I don't know who it is, let some individual equal suck-ass individuals who can eat a big fat dick dot, let's go with Tim Dog, okay? And so now we have some person who, or some individual that is a member of this list and is Tim Dog, the second case. Okay, so now we can actually write a program to execute different lines of code depending on who this particular individual is. Now we know that this individual can only be 3 things. This person can only be Eazy-E, Tim Dog, or Luke. It can't be anybody else. So if we write our switch statement, switch, some individual, okay, case dot easy, okay. Then we'll say print line, as the song goes, Easy E can eat a big fat dick. Okay, and we've also got case of. Actually, let's back up here and see what this error is about. Okay. Notice how it says here. Let's zoom in. Switch must be exhaustive. Consider adding a default clause. Okay, so let's talk about what that means. What that means is we've said execute some piece of code based on who this particular individual is. But we've only defined one specific case. We've only defined the easy E case. We're saying if this person is easy E, then print this line, easy E can eat a big fat dick. Well, we haven't included Tim Dog or Luke in any of our cases, and so our switch is not exhaustive. Now, this is actually one of the key differences between enumerations in Swift as opposed to Objective-C. In Objective-C, you wouldn't get any kind of a compiler error or warning at all about this. And so you would be able to write this code that would actually crash if this individual were Tim Dog, which we have actually defined the individual to be Tim Dog. This wouldn't have anywhere to go. It wouldn't know what to do because it's not actually executing any code based on something being Tim Dog. Okay, so that's a problem, and we can't compile it in Swift, but we could compile it in Objective-C. So what we actually need to be able to do here in order to get rid of this error is we either need to define a default case or we need to define all of these two cases. So first of all, let's start off just by doing a Tim Dog case and a Luke case just to complete this enumeration, to complete this switch statement. So we'll say case dot Tim Dog, okay, and we'll say print Tim Dog can eat a big fat dick. Okay, we still have that error because, well, we haven't completed the enumeration. So case.Luke, okay, and finally Luke can eat a big fat dick. Well, can eat a fat dick, I think is more specifically how it's said. Okay, so look, we've got all of the cases right here. All right, so we've got Easy, Tim Dog, and Luke. And now you'll notice that our compiler error is gone because our switch statement on this some individual who belongs to this set, this enumeration of sucka ass individuals who can eat a big fat dick, excuse me, our switch statement is exhaustive. It includes all of the possible cases. If it's Easy E, then we just say Easy E can eat a big fat dick. If it's Tim Dog, then we can just say Tim Dog can eat a big fat dick. If it's Luke, then we just say Luke can eat a big fat dick. So no matter who this particular individual is, we've got some means of handling that. Okay? And so our switch statement is exhaustive. So now we'll actually go to our console, and you'll see that our console output right here is Tim Dog can eat a big fat dick. Why? Really simple. It's because we defined this particular individual to be a member of this enumeration who is Tim Dog. So it prints the line, Tim Dog can eat a big fat dick. So if you remember earlier, it was suggested that we add a default case just to complete this enumeration on this switch statement. So we did one way so far. We've gone through and we've done Easy E, Tim Dog, and Luke. We've actually listed all of the elements of our enumeration. But instead of doing that, what we could do is, let's say, get rid of these two. So we'll delete these. And now we've only got Luke. and our switch statement is incomplete, and we still have this error. Okay, switch must be exhaustive. Consider adding a default clause. So let's just go ahead and do that. Let's just go case default. Oh, no, I think we just say default. We don't need to actually say case. Default. Print line. Not sure who, but someone can eat a big fat dick. Oh yeah, we got to do our little... Okay, so now our error is gone because we added a default case. So only if our individual is Luke will this say Luke can eat a fat dick. If it's anybody else, we're going to get this. That's the kind of behavior that we should expect, because this switch statement really only handles one case in our enumeration. So let's go and have a look at our console output again. And once again, now it says, not sure who, but someone can eat a big fat dick. Remember, this is our exhaustive enumeration of all of the individuals who can eat a big fat dick. In this case, because our switch statement doesn't exactly know if it's Tim Dog or Easy E, specifically, it's saying, I really don't know, but someone can eat a big fat dick. So this is kind of what we've got here. Enumerations are a really good way to handle what's called control flow in an application, and that's exactly what we've done here. We've said, okay, we're going to execute these lines of code right here, and if this particular individual happens to be Luke, then do this. If it's anybody else, then do this. There's a number of different types of enumerations you could have. A really popular and common one in an application is to say, okay, here's a certain type of connection that I've got coming back from a server. If it's a connection where we're getting people's profiles, then go and do this. If it's a connection where we're getting, I don't know, their list of friends, then go ahead and do this. Blah, 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 on and on and on. What's really cool about enumerations, specifically in Swift, is that, like I said, it forces you to be exhaustive with your list. It forces you to finish your entire switch statement. So you never end up not considering all of the cases that you initially wanted to put into your enumeration. That's one of the benefits, is that it forces you to handle all of those cases. As long as we declare that there are 3 specific sucka-ass individuals who can eat a big fat dick, Swift says, hey, you're switching on one of these, you're going to execute some code based on one of these, you better be able to handle each of these particular individuals that can eat a big fat dick. So there's more about enumerations coming up in some future tutorials, one in which we'll actually build a fully functioning application using enumerations. But this is just to kind of get your feet wet about kind of what they are and how you can use them specifically to execute different lines of code in your application.